Problem 4. The function is a polynomial equals 0. Alright, first, use the intermediate value theorem to show that there is at least one root. Okay, there is at least one root. So remember, intermediate value theorem is just if the function starts below 0, ends above 0, then there should be a point in between that is exactly 0, right? Or the other way around. If it starts above 0, it ends below 0, it's continuous, and it should be a point that the function equals 0. So we have to find 2 points, positive and negative. So the easiest point to verify is f0, right? f0 is 1. First, okay, what is fx? This is your fx. Okay. So first part, f0 is 1. And second part, so now you have a positive number, you want a negative number, so probably you can try f negative 1. So f negative 1, it's, right, if you do the calculation, it is negative 1. It's smaller than 0. Okay, this part is greater than 0. So the function is continuous. It's continuous on this closed interval negative 1 to 0, and your f0 and f1, they are different sign. Right? One is positive, one is negative, so the multiplication is negative. Then by the mean values, by the intermediate value theorem, there exists a point C between negative 1 and 0 such that, right, fc equals 0, right? Which means, right, this means at least one root. Okay, this means at least one root. Second part, use the mean value theorem to prove that it has at most one real root. So at most one real root, which means what happens if the function has 2 roots? There must be some contradiction, right? So the contradiction is, okay, the idea is quite easy. fx is this. Right. What about its derivative? Its derivative is this plus this, right, plus 4. So it is 3x squared plus 6x, sorry, plus 2x plus 1, right, plus 1. So it's 3x plus 1 square plus 1. And the square, something square, it's greater or equal to 0, right? So the result, it should be greater or equal to 1. Okay, so which means this function is forever increasing. So it will meet the x-axis only once, right? Then how do we use the mean value theorem to say that? Okay, by the way, this function is always increasing, so it can only meet x-axis once, right? It's always increasing, so it can only meet x-axis once. Then, if there are two solutions, if there are more than one roots, if there exists more than one roots, okay, then we call this root, let's call it, then let's say two roots are C1 and C2, right? Which means FC1 is 0, FC2 is 0. Okay. Okay, let's use another name for them. Let's call them D and E. All right. Let's call these two roots x equals D, x equals E. So fd is 0, fe is 0. Then the function is continuous, and let's suppose d is smaller than e. right? It doesn't matter. E is smaller than D, D is smaller than E. That doesn't matter. Then fx, it's continuous on DE. It's differentiable on DE. Right? Then there exists, then by the mean value theorem, there exists a C between DE such that f prime C, right, equals fe minus fd over e minus d. Fe minus fd, it's 0 minus 0, right? Because they are roots of the function, so it's 0. So you prove that there exists a point that the derivative is 0. However, previously we have proved that the derivative is always greater than 1, right? So these two parts, they contradict with each other, right? So it's a contradiction. It contradicts with the fact that the derivative is always greater or equal to 1, right? Then, which means our assumption, if more than one root, is invalid, right? So our assumption is wrong. More than one root. Okay, greater or equal to 2 root is wrong, right? Which means at most, right, fx equals 0 has at most 1 root. Okay. Then the last part, combine A and B to conclude that there's exactly 1 root. So A tells you there's at least 1 root. B tells you there's at most 1 root, right? Then you combine them, right? You should conclude that there's exactly 1 root. Okay.